Hello, today I will answer the interview questions in the task 5.7. The first question is about what does the CRISP-DM methodology for data mining entail? What does the data analyst do in each step? So the CRISP-DM methodology stands for the cross-industry standard process for data mining. It provides a systematic, thorough and validated framework for data mining, and it consists of 6 phases. The first phase is business understanding. This phase includes understand the business goals that align with data mining projects. The second phase is about data understanding. In this stage, we gather and assess data for quality issues. We calculate descriptive statistics for initial insights and document the process. The third phase is data preparation. In this stage, we prepare the data for analysis, resolve quality issues, and define new data if needed. The next stage is the modeling. In this stage, we decide on a model, design a test plan, construct a prototype, and document the process. The fifth stage is about evaluation. In this stage, we assess if the model meets the business goals, validate output, adjust as necessary, review per process, and prepare for presentation for deployment recommendations. And the last phase is about deployment. We implement the validated model into the business process, monitor performance, and investigate change to outputs. The second question is to explain what needs to be done before you can forecast time series. In other words, what does time series analysis involve? Time series forecasting is a statistical method to predict future values based on historical data. Business, economists, and finance often use it to anticipate trends, plan for resources, and make strategy. Methods used for time series forecasting consider time-dependent patterns in the data, such as trends and seasonal variations. Before forecasting a time series, several steps need to be taken as part of the time series analysis. After data collection and cleaning, we must understand our data by doing an initial statistical analysis. This includes identifying any underlying trends, seasonal patterns, or cycles. It also involves checking for stationarity. If not, we must transfer the data into stationarity. As many time series models assume the data is stationary. The next stage is model selection. An appropriate time series forecasting model should be selected based on the data characteristics. This could be an Arima model, Facebook Prophet model, or even a machine learning model. The next stage is model fitting and validation. The chosen models is then fitted to the data and its performance is validated using a whole-data sample or other cross-validation technique. Finally, the model can be used to forecast future values. Time series analysis is an iterative process. We may need to repeat these steps as we refine our model and approach. The third question is discuss the main principle of data ethics and what companies or organizations could do to uphold these principles. Data ethics, the moral guidelines for data handling, encompasses. The first one is transparency, which means entities must disclose data practice, including data collection, purpose, usage, and sharing. The second point about data ethics is consent and autonomy. That means entities must respect for personal data rights, requires informed consent before correction. The third about the ethics is about privacy and security. That means protection against unauthorized access with robust data security measures is crucial. The next one is about fairness and non-discrimination. That means regular audits prevent unfair or discriminatory data practice. The last one is about accountability. Entities should have procedure to mitigate any adverse impacts on the data used. To uphold this principle, companies and organizations could take the following steps. The first one, to develop and implement a clear data ethics policies. The second step may be regularly train employees on data ethics and related legal requirements. The next step is to implement robust data security measures to protect data privacy. The next step may be regularly audit data practice for compliance with ethical standards and legal requirements. Another suggestion is to establish a system for addressing data ethics inquiries and complaints. The last suggestion is to strive for transparency in data collection, usage, sharing, and storage practice. The next question is: imagine your analyst at a financial services company with concern about bias in measuring a predictive model. How would you raise your concerns with your manager? Make some suggestions for how to avoid measurement bias in the future. To raise concerns about potential bias in predictive model, I would first gather all the relevant details and evidence supporting my concerns. This might include data that shows skewed results or the methodologies used that may have led to the bias, or research on similar situations where bias have occurred. I could then request a meeting with my manager to discuss about this concern. During the meeting, I would explain my findings clearly and objectively, emphasize the potential impact of bias on our analysis and decisions. I would also propose some steps to avoid this bias in the future. These steps might include ensuring the diversity of the datasets. Our datasets should represent all segments of our customer to avoid our fitting or underfitting in particular group. The next suggestion is to regularly reviewing and updating the model. The model should not remain static and should be reviewed and updated to ensure it remains relevant and unbiased. The next suggestion is to do cross validation. These statistical methods reduce the model bias and improves generalizability. The last suggestion is to make independent review. We have our model independently reviewed can help identify potential bias we might have overlooked. The last question is: explain the difference between regressions and classification models in predictive analysis. When would you use one of these models over the other? So the regressions and classification models are two primary types of supervised learning algorithms in predictive analysis. They differ in the type of output they produce and the kind of problem they solve. Regression models are used when the output variable is continuous and quantitative. For instance, predict house prices, forecasting sales, forecasting stock price, or estimating the growth rate of the company. On the other hand, classification models are used when the output variables is categorical or qualitative. These models are used to classify data into predefined categories. For instance, classification task predicts whether an email is a spam email or not, or a transaction is fraudulent or not. In these cases, the output is a category like spam or not spam, fraud or not fraud.